Hi everyone, welcome back to my channel. If you are new here, do not forget to like, subscribe and share. So today's video I am going to explain for some problem in a lead code 18 in an array. So let's solve this problem. Let's understand the problem statement first. So they given an some array so in an unsorted fashion. So we want to take four element like 1, 0, minus 1, 0 like that. Four element we want to take. Four element we want to sum. The sum of this four element will be 0. We will check whether this is our target element. If it is equal to our target element, we are going to store this array in a some variable. Okay. So this is what the problem statement. We will solve this using this conditions and optimal approach, of course, sorting plus a two pointer technique. Yeah, I already explained these conditions in a three sum problem, but slight variation is there. So first condition will be like we want to add up the four element from the array, and we will check whether it is a target element. If it is, we will store that set of subset. So next the condition will be it should not point to the same condition like I, J and of course L. I, J, K and L should not be pointing at the same element either of them. Like it should not pointing at two element also like this. I and J should not be pointing at same element. That's what the condition is. It should not be like I is not should be equal to j and not should be equal to k and not should be equal to l, and another last condition is same for some problem also. So output element should not be same or duplicate. Here there are unique four elements there, another minus 2 minus 1 or 1 2, another like this array it does not exist. So it should be like this. We should not be having the duplicate elements. So this is what the condition is. Let's solve this using an sorting and two pointer technique. First I am going to sort the array, then I am going to apply the two pointer technique. First I am going to sort the array here. So this is an given array. I am going to sort it. So minus 2 will be the first and minus 1 next, then will be 0 and again the 0 and again 1 and then next 2. So there are 6 element here, also there are 6 element. So this is sorted version of a original array. So this is sorted. What I'm going to do, I'm going to iterate from here. I will take this as an I, next to that I'm take it as j, and next to that I am going to take it as k. At the last I am going to take it as L. So this is same as three sum problem. If you do not watch my three sum problem, please go and watch that so that you can able to get a better idea of solving this problem. So let's solve this. This is an two pointer technique look like. So I am going to move the K and L, and then I am going to move the J, then I am going to again move the K and L, so that it is going to solve my problem easily. First it is pointing to the this many elements. Let's solve this first. So minus 2, again we want to sum this up, right? So plus 0 plus 2. So what will be the answer? So minus 3 plus 2, the minus 1. We will check. We will given some certain target. It is either 0 or 8, not like three sum problem. In three sum problem there is fixed. If it sum is 0, we want to return the array, but here they would give some target. Okay, so here the minus 1 will be my answer. We already sorted, right? So we will check whether the target is 0 now. Okay, so this is target. Okay, this is 0. So it is less than the 0, right? So minus 1 is less than the 0. If it is less than the 0, I already explained. If it is less than, we want more number to add, right? So that it matches the 0. If it is given 8, same thing. Minus 1 is again the smaller than the 8. So we want to increase some number to match the 0. So like that I'm going to increment the k. So here also same thing will come. Most probably we will avoid this in a condition loop. So same thing, minus 1 will come. It is smaller than 0. Yeah, we will move the kth pointer again. So k is now pointing to the 1. So it is going to change and become the 1. So minus 3 plus 3, what will be the answer? Yeah, here I am getting the answer as 0. Yeah, it is equal to my target. It is equal to my target, right? So I'm going to store this element in a certain array. Okay, minus 2, minus 1, 1 and 2. So this will be my first answer. Okay, here if I get some target value as correct, then I'm going to move the k and l simultaneously. So l is pointing at here and k goes here. If the k and l crosses or pointing to the same condition, so here we will going to end up the loop. So always k should be smaller than the l. If it is equal or it's exceeded the l, then we will stop the loop here. Okay, for better clarity I did the rest. So let's continue the loop. Now j will move to the second index from first index. Okay, then from jth friend it will be k, at the last it will be l. Let's calculate these elements. So minus 2 plus 0 plus 0 and plus 2. So this is also giving me the answer as 0, and it is also equal to my target. I'm going to store this as well. So minus 2 comma 0 comma 0 comma 2. So this is going to be my second answer. Okay, then I'm going to move the both the pointer. Now L will be pointing at this position and K also is pointing at this position. Here the loop will going to end because K is like at the third index and L is at fifth index. K should be smaller than the L, but in this condition 4 is not smaller than the 4. So here the end of the loop. Okay, then J will move to the third index. Now the j is pointing at the third index, next will be the k, and at the last the l will be pointing. Let's calculate this element. Minus 2 comma minus 1, sorry, here 0. Okay, 0 1 and 2. If you calculate here, the answer will be plus 1. It is actually the greater than the target 0, right? If it is greater, we want to move the L pointer. Now the L will be pointing at here. We will end up the loop and J will eventually go here, pointing at this position from here. And K will be the next here itself and L also will be pointing at here. So for here, we would not take this as element. We will consider this is also the end of the loop. Then we will move the ith pointer for the first index. Let me erase this so that you can able to get properly what I'm saying. Now the ith pointer move from 0 index to 1 and next will be the j. The j next will be the k and at the last I'm going to take the l pointer. Let's calculate these elements like minus 1 plus 0 plus 0 and plus 2. So I'm getting the plus 1 as an answer. So it is greater than the 0. If it is greater, I want some smaller number to eliminate to match the 0, right? So I'm going to move the L pointer. So here the L became 1. So here I am getting the answer because it will give me the answer as 0 if it is equals to my target. So I'm going to store that whatever the element is there, like -1 0 and again the 0 and 1. So here what I'm going to do, I'm going to store, this is my third answer, right? So I'm going to store that and I'm going to move the k and l pointer. So here l will be pointing and k will be goes here, right? So it crosses my limit. I will just move the j pointer next. So next the j moves from second index to third. Let's calculate this, like -1 plus 0 and plus 1 plus 2. So here I am also getting as plus 2 as an answer. Is this greater than the 0? So I'm going to move the L pointer here, eventually the end of the loop, so that I am going to move the J pointer again. So if I move J pointer here, and K will be pointing at this position, and eventually L also. So there is no point in moving the J pointer. I will move the I pointer next, okay? So now I is pointing at the second index. Let's calculate this sum. So the sum will be like 3, right? So sum is yeah, sum is greater than the target. If it is greater, I'm going to move the L pointer. So there is no meaning of moving it. And also, if we move J pointer also, there is no point in moving K and L, right? So eventually if you move I pointer also, you cannot able to take another element in a different element. So here the end of the loop. So and we will return the whatever we stored in a uh, temporary variable. We're going to return it to a output console. So same like -2 -1 1 2, again -2 0 0 2, -1 0 0 1. So this is going to be the answer. So this is how you're going to solve this problem. So I already solved this problem example. So give it a try and solve this problem. Now first you are going to sort the array, okay? So you're going to sort the array. Then you are going to take ith pointer at the beginning. At next you are going to take it as j. So this 2 I and j is a loop, okay? It is a loop. You want to write it in a code. Next will be the j. Next pointer will be k. At the end you are going to take the l pointer. You want to move the k if it is smaller number. You want to move the k if it is greater number, so that you can able to match the target, okay? So this is how you're going to solve. If it end of the loop, you're going to move the jth pointer. If it jth end the loop, you're going to move the ith pointer. Like that, you're going to solve this problem. So give it a try and solve this, and let I will put the answer in description so that you can able to get it. So let's solve this in a leetcode. So now I am in the leetcode problem. Let's solve the 18 sum problem. So given an array nums of n integers, return an array of all the unique quadruplets like nums a, nums b, nums c and nums c, such that it should be at the 0th under and n's inside. So a, b, c, d should be different elements. So if you add up these 4 elements, it should be giving the target. You may return the answer in any orders you want to. Let's code this up. So I'm going to take n, that will be the length of the array, okay? Then I'm going to construct the array list, okay? Here I'm going to construct the array list. For storing the answers, I'm constructing the array list. So this is, I'm going to name it as answer, and let's complete this construction. Yeah, this is what the array list construction look like. So I'm going to sort the array first using arrays.sort function. I'm going to pass the array, right? Then I am going to loop it using ith pointer. So then I am going to make certain conditions. If it I is greater than 0, you can able to take I is not equal to 0 as well. So for this condition, I will write if it is equals to the previous same element, I want to continue. I do not want to calculate that. So this is an edge case we want to handle. Okay. So next I'm going to write j loop. It will be starting at the front of the I and it is ending at the last, and j plus plus. So here also I am going to write some edge cases, like if j is greater than 0, sorry, I plus 1, because it is the starting condition, right? If it is starting, we do not want to calculate here. If it moves forward, we want to check with the previous one, like j, if it is equals to nums of j minus 1 previous element. Yeah, we want to continue, we do not want to calculate same element again and again. Yeah, then I'm going to take k pointer, which is pointing at the front of the j, right? So it should be j plus 1. Yeah, j plus 1. Then I'm going to take L. It should be pointing at the last index every time. Okay. I'll use while loop for iterating, moving I and k and L. Okay. Probably I will take some. I store it in a long variable because of memory constraints. Yeah. Let's solve this in a separate using this like syntaxes. Sorry, I did put it twice, right? So yeah, change it and become j. Now I am going to store the array of k, then I am going to store L. Okay, after that I am going to check if sum is equal to the target. If it is equal to the target, what I am going to do, I am going to store that in an answer variable, right? So answer dot add function I'm going to use. So arrays dot as list function, probably it's it will return the fixed element. If you stored any number, it should be at the fixed size length. Okay, it would not change later. And I'm storing it here. If it is equals to target, I'm going to store this all element in an array. Then I am going to increment the k pointer as well as L. I am going to decrement it. Yeah, one more condition for this, and I'm going to make sure k should be smaller than L and it should not contain any duplicate elements. For that, I'm going to write down for whatever return I for I and j. For that, I am writing k also, and as well as I am writing L. This is a small edge cases. It's quite save the times what you calculate. Okay, these small things can able to change your program for better run. L plus 1 if it is, sorry I guys I didn't, yeah, L plus 1 I'm going to decrement that. Yeah, if it if the sum is, whatever the sum is smaller than the target, at that time what you going to do, you just going to increment the k pointer, right? Because you want to need some more element to match up the target. Else, if it is else condition contains a small sum is greater than the target. If it is greater than the target, we need some lesser number, so that we will go at the left. We will move the L pointer so that we get a small element. At the end, I'm going to return the answer. Okay, I'm going to return the answer. So let's run this. Yeah, it's accepted, and let's sum it up. Yeah, it takes time complexity as a big of n square, and space complexity is big of 1 square 1. So if you like this video, do not forget to like, subscribe and share.